Welcome back to our lectures. This chapter is about Kafka, which is a distributed, publish, subscribe messaging system in Hadoop ecosystem. Again, before jumping into the main lecture, please have a look at the objectives first. We hope that after this course, you can be able to understand the basic concepts of Kafka and the system architecture of Kafka. Firstly, we can have a look at the introduction to Kafka. Okay, just as shown in the slide, Kafka is a distributed, partitioned, replicated, and zookeeper-based messaging system. This definition shows several features of Kafka, and the key point is that Kafka is highly dependent on zookeeper. And perhaps you are wondering, what is a messaging system? Simply speaking, a messaging system consists of one or multiple queues for message delivery. And each message queue provides an asynchronous communication protocol, which means that the sender and receiver of a message do not need to keep in touch with each other at the same time. The message sent by the sender is stored in the queue until the receiver gets it. And you can consider Kafka as the postman or the newspaper boy who serves as the intermediary between the customers and the producers. By the way, currently, there are three types of message queues in production: ActiveMQ, RabbitMQ, and Kafka, among which Kafka is the most suitable one to be used in Hadoop ecosystem. And as for its main application scenario, we use Kafka to support Flume for data collection or use it for message delivery. What's more, in the title, we mentioned that Kafka is a publish-subscribe messaging system. But there is another type which is called point-to-point messaging. So what's the difference? Actually, it is really easy to understand the point-to-point messaging systems. Just as shown here, the key point for this type is that a message in the queue can only be consumed by at most one consumer. And once consumed, the message would be deleted or moved out from that queue. That is why we call it point-to-point. But as for publish-subscribe messaging systems, things are totally different. In this case, a system could have multiple queues, and now the consumption unit is called topic. To receive messages from the system, consumers need to subscribe to one or multiple topics, and each message in a topic can be consumed by more than just one consumer. To make an analogy, you can consider using this type of messaging system like using YouTube. Suppose that you want to learn big data from YouTube. You need to subscribe to a topic called big data, or maybe subscribe to a YouTuber who teaches big data very well, right? Then, after a subscription, you will be notified every time the video is updated, and meanwhile, others could share the same video with you even after you finish watching all of them, right? So this is just an easy way to understand the concept of publish-subscribe messaging system. And again, Kafka is just a typical publish-subscribe messaging system in production. And here, we list several features of Kafka. Firstly, the time complexity of Kafka is of order 1, which means that the reading and writing efficiency is independent of the data size. So it is very suitable to process massive data in terabyte or even petabyte level. On top of that, the throughput of Kafka is also awesome. Here, we mentioned that a single node system can transmit 100,000 messages per second. This is really a large number of data. Moreover, in Kafka, the messages can be partitioned and distributed, which consequently improves the concurrency and access efficiency. And meanwhile, the order of messages is remained perfectly by Kafka as well. Therefore, Kafka can be applied in both offline and real-time data processing in production. And that is the reason why more and more people prefer to use Kafka in Hadoop platforms to assist big data analysis. And if the performance of Kafka is not good enough, we can use the scale-out strategy to reach a linear scalability easily. Okay, that is all for the introduction part of Kafka. Next, we can have a look at the architecture and functions of Kafka.